Okay, so we will continue to move on to the next speaker, Professor Trucco. And I think you're here. So can I briefly introduce Professor Trucco? He's a Fellow of the Royal Society of Arts, UK, IAPR Fellow, AAIA Fellow, Fellow of the British Machine Vision Association, NRP Chair of Computational Vision in Computing, School of Science and Engineering at the University of Dundee, Honorary Clinical Researcher of NHS Tayside and Adjunct Professor at Chinese Academy of Science. So, Professor Trucco, the floor is yours.
Thank you very much, Professor Wang, for the nice introduction, and thank you to the board, of course, for inviting me to share our research with you all in this event. The other thing I must share is my screen, so I'll try right now. This should be this one. Let me see. Right. I assume you can see my screen at this point?
That's right, we can. Thank you.
Lovely. Thank you. Okay, so my talk today is a general introduction to our research on retinal image analysis and specifically biomarkers for systemic diseases. This is focused on dementia. And it is of necessity a part of the work we've been done in the best part of the last 20 years. I'll give you a very quick introduction to vampire and what it means. That is the universe within which we move. I'll show you very, very briefly what we mean by retinal measures. And some of the challenges, the technical challenges behind computing these retinal measures. I'll provide some examples of projects aimed at using retina either directly, so images like the one behind me, or measurements, particularly of the vasculature, in order to calculate, well, estimate risk of systemic diseases. Again, we'll focus on dementia, we'll touch upon cardiovascular as well, and then one slide of summary and challenges. Okay, so first of all, vampire is an acronym which has served us very well in these 20 years. Vessel assessment and measurement platform for images of the retina. It says it all, but it is a bit skewed towards the technical part. This is a very brief statement of our mission. I should immediately say that vampire is a two-university operation. There's myself and my colleague and partner in crime, Dr. Tom McIlvray at the University of Edinburgh. Our mission is divided in three parts, if you like, or composed of three elements. Research, of course, our research is clinical motivated. There's ultimately the ambition of doing something useful. This is a translation part that make a difference to healthcare, all aspects of our health society. And of course, there's a training element in the sense of introducing the next generation at this point. In 20 years, a few generations of people have gone through our training and teach them what is important, particularly from the interdisciplinary point of view. Okay, so this is very briefly just to give an idea of the ecosystem. There's technical research, medical image and data analysis. There's medical research that we support in many projects at this point, typically consisting of people, clinical teams who have repositories of planned prospective repositories of retinal images linked to patient data, and come to us asking for support with extracting measurements or doing data analysis or deep learning solutions. Nothing of this would happen without a solid presence of support from clinical data repositories and the safe haven singular or safe haven plural, in which our own data from our own clinical groups in Edinburgh and in Dundee are. Again, this is a separate intersecting big topic. We have industrial collaborations, of course, practically all of us. In two senses, we collaborate with external companies and we have our own spin out for commercializing technologies. Okay, let me tell you briefly something about, very, very briefly, what we measure from the retina. So this is a typical fundus camera retina. I hasten to add the fundus camera is one of many possible devices, several possible devices which are used to observe the fundus of the eye, so the retina. This remains, I think it's safe to say, the main one in clinical practice, although of course there's OCT, and there are various other, OCT is becoming very important, but there are others. So what measurements do we take from images like that? The first thing is we automatically establish landmarks. So for instance, you have to find automatically the optic disc. In this case, you see the estimated and real position, real annotated position of the center of the macular regions. And then of course, somebody, thank you very much. And then, of course, the vasculature, the vessels here are little veins and arteries. Here, there's just a hint to the fact that we work with multiple types of images. This is an ultra-wide field of view images taken by a scanning laser ophthalmoscope, and we have software to do a similar thing for these sensors. One particular measurement of the vasculature, in particular the blood vessels, I want to stress is the fractal dimension. Again, qualitatively speaking, the fractal dimensions measure a complexity of a pattern. We're talking here digital, pixelized. So, you know, do not think of the kind of continuous patterning Mandelbrot's books. We worked a lot on this. Here are a few papers, very recent. The fractal dimension is attracting increasing interest because there are associations with risk of various systemic diseases, which have been detected in multiple data sets. But of course, is one, have to believe me, is one measure of the many that can be taken, like width of vessels, tortuosity of vessels, location of various landmarks, for which you can have proof. You can ask a doctor, is this true? You know, what do you think is the width of the vessel? Where do you think the optic disc is? But you cannot ask a doctor what is the fractal of this vascular network. So there are also discussions about stability and reliability, but I wanted to single this out because there's a lot of interest about that. In my personal view, one crucial, if not the crucial point after developing clever algorithms is validation. I have only this slide. I could talk for a long time, and we work a lot on this. We, like a lot of people in the community, discover now know very well that it is a very complex and multifaceted task, which goes well beyond the technical validation, meaning rock curves, AUC, and things like that. I don't have time to go into details, but if anybody is interested, please do contact me. There's a lot to be discussed and researched. I move fast here to the retinal biomarkers. So a few examples of projects on retinal biomarkers for specifically dementia, cognitive decline, but also I'll touch upon on other things. This triangle, this is a slide contributed to my colleague and friend, Dr. Alex Doney, in the School of Medicine on our university. This is the triangle of elements which provide the data for a risk assessment in our vision. So you have this so-called retinome, so any information you can extract from images of the retina, data about the retina. You have the genome, because a certain amount of the bad things which may happen to you are unfortunately written in your genes, and you cannot change that. And then there's what we call a clinical phenome, so a lot of information which comes from other parts of the body, essentially. Okay, we work with an international community of partners, and we work with multiple data sets of increasing size. I want to mention only one because this is a product of the research community, of the clinical research community in our university. It is Goddard's. It's a very rich resource, fully longitudinal, the best part of 15 years. About 60 people, of which about 9,000 diabetics, with full genome profiles, history of medicine taken, history of measurements, many with CT or MRI scans, and practically all, I would say all, with retinal images, because Scotland has a national program for diabetic retinopathy control, and eye exams are offered to all the diabetics or suspected diabetics. We did some investigation with GWAS studies into the genome and the retina, and we published some years ago some results on loci that we found out, which seemed to have to do, were associated in the GWAS with the coronary artery disease, or disease cardiovascular, of course, which is something that the relation between retina, genes, and other things I'm describing in a moment is something we are investigating in the context of dementia as well. And here is some results. Again, I will not take you, of course, through the figures, but the interesting point here is that we have results at the moment with about 6,000 patients in a prospective study that indicate that retinal vascular measures can actually increase the prediction accuracy of risk, in this case, of dementia. There's, of course, a lot of details that I am skipping, independently of genes. So independently means that it seems from our results that information brought about by the retina complements the information that you have in your genome. And this is something we have looked at in a different piece of work with our PhD student here, Syed. So this is in the cardiovascular context. We looked at the value of the standard cardiovascular risk coefficient or score that is used in the NHS, in the National Health System in the UK, by general practitioners. So the first port of call when you go to the doctors, and this is based on, I believe, 6 simple measurements, and produces a number which is your risk of an adverse cardiovascular event within the next 5 years or so. So our results, again, going very, very quickly, our interesting result is that we found in this particular population that the predictions of cardiovascular adverse events produced by retinal information was rather well associated with the prediction generated by the clinical scores in actual use, but did not associate at all, graph on the right, with the genetic risk score. Again, we can discuss on the how this genetic risk score was exactly formed, but this was essentially generated by our cardiologists, in particular Dr. Ifi Mordi here, and he looked at loci that are known to associate with cardiovascular problem, built a weighted sum, and that was our genetic risk score. The key information behind here is that it seems, and I stress it seems from this particular sample, that retina and genes complement each other, which is a very good piece of news. And let me give you some not so good piece of news. So it's good that we have this collaboration with some Canadian colleagues in Dr. Piger's group in Canada. They have brought with them in this collaboration a 50,000 strong Canadian data set, very well organized. And again, they've used our software, Vampire software, to look at the fractal dimension, to compute the fractal dimension in this cohort and estimate associations with various things. So the bad, and here is the bad news. There are associations with various factors, several of which replicate our results, but they found no association with dementia. I should stress that this study used particularly the fractal dimension, whereas what I was describing before used more measurements. Okay. I want to mention another collaboration, two more collaboration, one with Duke University in the States, where using multiple sensors, and in particular, ultra-wide field of views images and our software, they are looking specifically at cognitive decline and dementia. Again, we don't have time to go into details very much. And the last collaboration I want to mention is with Moorfields at UCL in London. This is a group led by Dr. Peter Skeen, and Dr. Wagner here is one of the PhD students who explained the job. They have put together more than 2 million retinal scans of 353,000 patients, and they have run fractal dimension software, Vampire fractal dimension software, on a subset of this, and for instance, found some results. So they found a strong inverse association with between fractal dimension and all-cause dementia. Again, there are some potential explanations for this, but this is a very large data set, and I believe we're very excited to be in this collaboration. Okay, so let me conclude briefly, because I think there are 2 minutes left in my slot, and just a very, very quick comment on where are we in terms of prediction of say, retinal prediction of risk for systemic diseases. Can we do it? Can we not? And so on. So there are good news and bad news represented here by some Japanese cat emoticon. So the good news is that there is mounting evidence that retinal information does associate with the risk of systemic disease, the progression of systemic disease, and I keep referring, of course, to dementia, in particular vascular dementia, of course, and cardiovascular disease, but also other things like complications of diabetes, chronic kidney disease, and so on. The really interesting, and this is part of the good news, the really interesting thing is that it seems also that information extracted from the retina, if coupled with other phenotypic and genomic information, information from the retina can strengthen the prediction and make it more accurate. So there are more good news, but these are, to me, two main things. There are some bad news, which make the cat cry. One is that at the moment, there are still contradictory results reported in the literature. So this implies that the whole research is not at a stage where it can be safely translated into a clinic, clearly. And that is the point number two, which makes the cat cry. We are still far from clinical tool. It is the slightly upsetting, I find, piece of news that this research, not only ours, but in many groups around the world, has been going on for the best part of 20 years. We are still not there with a robust clinical tool, but we keep working towards it. The fact that we are not there yet doesn't imply that we will never get there. Okay, so I think my time is over. I really don't have time to go through challenges, and so let me finish here and thank everybody. There's a lot of people I should thank, but let me thank again AAIA for inviting me, and I'll put my email in the chat. Thank you very much.
Thank you so much, Professor Trucco, for your wonderful presentation. Yeah, it will be good to have your email in the chat. And let's look forward to lively discussions through chat. Yeah, thank you.